Okay. So I'll just do a show of hands. Who here heard me talk at AI Camp a few months ago about Cascada? One, two, a few. Okay. So I know the abstract looks the same, but actually that's the old abstract. This is a completely different talk. It will be very different. So since the last talk, GPT has only continued to grow. And what I'm going to talk about today is Cascada, but from this perspective of real-time AI and real-time generative AI. And I think this is really cool because everything that we've seen so far has been generative AI, or most of what we've seen so far has been generative AI that waits until you ask it a question, or waits until you're sitting there waiting for a completion. But what would it look like if that was really watching what you were doing and helping you? And so we built this example app to play around with what would real time look like. We did it as a Slack bot. Right now, Cascada has been acquired by DataStax, so I spend a lot of time on the DataStax Slack. It's fully remote. I'm at home. Lots of Slack messages going by. I'm sure some of you guys can relate. And so we built this bot to kind of keep us in the loop. And so we played around with that. And so as an example, this is from one of the Slack channels. Preeti, one of our PMs, said we were launching a new marketing campaign. Let me know if you have any suggestions. The Slack bot was like, hey, you might be interested in this conversation about these requirements for the Gen AI capabilities. Obviously, I'm an engineer working on that team, so I probably was interested in those requirements. But I'm not going to kind of talk about the app. We're not in the business of selling those apps. I'm going to talk about how we built it, because that's what I think we're all here to explore. So how do we get to real-time generative AI? How do we build this? And I think, it's important to recognize GPT is a huge part of this. A year and a half ago, if you wanted to build an ML product, you would have to go collect a huge amount of data, spend a lot of time learning how to do data science, training a model, and it wouldn't work. And you would do it again and again and again, and it would get better and better and better. And eventually, you'd have a model. And then you could decide if you wanted to go make a product around whatever you were trying to solve. But with LLMs and Gen AI and these foundation models, you can just take something off the shelf that gets you pretty far. And you can wait until it stops working, and you want to make it work a little bit better to figure out fine-tuning and few-shot learning and all that kind of stuff. Similarly, there's AI as a service. OpenAI's APIs, Hugging Face, things like that make it super easy for you to go use these models without having to figure out how to manage the GPUs yourself and run clusters and stuff like that. And so the final piece that's missing in our view, or that we were working on, is how do we connect real-time data to generative AI? I want to go build this Slack app. How do I get all of these messages that are being sent in Slack continuously into a spot that I can use Gen AI to say, hey, you should go check out this conversation that's happening right now? You can think of it as there's tools like LangChain, Llama Index, and stuff like that, but these are very batch centric. Run them periodically, load all of your documents into your vector database. That's great if you're just waiting for somebody to ask a question on documents that have been written. But it doesn't really help with that real-time piece. So I look at this as kind of where Cascada fits and what we're going to look at a little bit further. So how does GPT, the Slack bot, work? Well, at a high level, we fine-tuned a model to figure out when I might be interested in a conversation, and then we just ran that custom LLM. But how do we get there? We started by using Slack's API to pull down a history of all of these conversations, then did some compute to kind of reassemble the conversations as they were happening, and generated a bunch of prompts of this conversation was happening. Here's my fine-tuning example. And then in real time, we kind of have to do the same thing. Go connect to all of the Slack events as they're happening in real time, do some more compute over that, make the same prompt, and feed that into this model that you fine-tune. And then call into the Slack's notifications API to send a message to you. In building this, we created a bunch of hypotheses and tried a few different approaches. So we started by saying, okay, look at the recent messages in a channel and try to predict the reaction, if any, that users might have. Thumbs up, thumbs down. What are people reacting to? Worked okay. Then we started thinking about, what about the next user that will reply? So instead of waiting, like just thumbs up, everybody might say thank you to a message. That doesn't mean they need to go look at it right away. But whoever replies might be a pretty good signal that they should be notified if a similar message comes up. Then we did kind of the same thing, but with a set of users. And we also did kind of the same thing for conversations and making messages out of the, making kind of fake conversations where we saw a bunch of messages in around the same times. And we found that kind of using the conversations in Slack and making these kind of fake conversations around these messages all happen in a channel in quick succession, they're probably related, is what really worked the best for us. But there's a really long blog post written by one of the engineers that worked on this about all the different steps that we tried to make the model. I'm not going to go into that super deeply. If that sounds interesting, that QR code should pull up the same as that link, and that'll go to the blog post that has a lot more details on kind of this process of building this Slack bot and training the model. But what's interesting here is how much we had to try all these different hypotheses and try different ways of taking that historic data and building a model or fine-tuning a model. So even though the foundational models make it easy to get started, you still have to iterate a little bit, but it's iteration that you can do as a software engineer. You don't need to be a data engineer and have years of schooling to do this. You can just kind of say, well, what if I prompt and say, who's going to respond next? Does the fine-tuning give me good answers? And then going back to this original, this picture of like the process, what is hard about this then beyond this iteration? What's technically missing here? And so the things that we can talk about is we can look at aggregation and context. We have to look at all of those Slack messages and extract the ones that happen really nearby and kind of make these fake conversations, because not everybody is great about using the conversation threads in Slack. We need to be able to do this for the Slack history, but also the Slack real-time events, so that we can kind of use the same logic to make our past training prompts for fine-tuning as we do when we're applying this model in real time. Because otherwise we're like asking the model to do things that we didn't fine-tune it to do. And a big one as a developer is all of the infrastructure necessary to use traditional stream processing and real-time techniques. You're setting up distributed clusters, managing a Kafka stream or a Pulsar stream, managing Flink or Spark to do stream processing. And Cascada helps with all of these. And that's why we like to say it's real-time Gen AI without the fuss. So it's built on this concept called time streams or timelines that I talked about before, and you can go read the docs or watch one of those other talks. But these really let you compute and create prompts over the entire history of those conversations, all those messages, all of your past events. And you can reason about, like, has there been inactivity? Are there gaps of activity, bursts of activity? It has this ability to do historic replay. So you can work with your history and your real-time data all in one place. Make your training examples, fine-tune on them without having to write two different data processing programs. And you can do all this starting locally and scale when you need to. You don't have to deal with persistence and durability and things like that. You just write the application and it'll scale with you. I won't spend a ton of time talking about kind of the Cascada architecture. Beyond kind of what you worry about is your real-time data and your application. And you get that into Cascada through a Python library. And then Cascada has this Rust compute engine built on Apache Arrow and columnar compute. It's very fast, gives you the answers, it manages state for you, durability, restarts, things like that. But at the high level, the important piece is your application in the Python library. And so going back to our GPT process diagram, really writing this and prototyping this, and it took us about 100, 200 lines of code. The link will be at the end. Is really about using the Slack API and getting your historic data into Cascada, using the Slack API and getting the real-time data into Cascada. And then you just write what you want your prompt to be. You make your fine-tuning examples and fine-tune. You start running the same prompt and hooking that up to the notification. This is some of the Python code showing some of those pieces. At a high level, so we import the Cascada library at the top, and then we kind of say, okay, take all of the messages, the converse, and group them by the channel and the timestamp, and kind of this is making the conversation. So take the 20 most recent messages in each channel. And then we have a user-defined function here that turns that into a prompt string. And then at the end, we say, okay, take the prompt and the conversations, and that's our outputs. We make a stream of records or a time stream of records. And so this is kind of the computation necessary to collect for every channel in your Slack, the 20 most recent messages. It also uses the thread, if there is a thread. This thread TS here as the secondary key is the timestamp that a conversation starts in Slack. Then kind of this next piece this is just Python code using the Slack API. This is I pull in a message, I turn that into a Python dictionary. Then at the bottom, this is the one piece that I had to do where I take that message and I push that into Cascada as a new row. And say, hey, here's a new message row. Do stuff with that. And then kind of the final piece here is that I can go and say, okay, now Cascada, please run and generate all of the outputs. And I want the rows, and I want those as they happen live. And so I just start asynchronously iterating over that. And so within one Python application, these 3 streams of code, I define my features, and I can run them historically if I, just using Parquet and the Slack APIs. But here I'm doing kind of the serving thing. I'm pulling data from Slack and running that through Cascada, collecting all of these conversations. And then I'm like for every output that it makes, I'm also now able to run the OpenAI API. And then for every interested user that's predicted, I can send them a notification. So I built this like real-time app pretty easily. And so that's what Cascada is hoping to enable, these real-time AI apps. You can process events in real time to build these proactive applications. You can bring your historical data and your real-time data together, so you can train your models or fine-tune them, and you can use these simple tools to build this next-gen generative AI app. And so, start to imagine kind of the possibilities. Right now we're seeing everything that generative AI can do, but think about what could you do with real-time AI, where you use recent information about the user and their environment to make a prediction? What can you do with reactive AI, where you're watching things as they happen and you're able to react immediately? I showed sending a Slack message, but other ways of reacting. Or what could you do with proactive AI, where it could actually identify an opportunity to act appropriately and do that automatically on your behalf? So Cascada is this open source project. Like I said, in the past, it was much more about queries and stuff like that. Now it's all available in this open source project. You work with it in Python. You can see the docs for this new Python version up here. That QR code will take you to the Slack invite. It's also up there as a link. And if you want to see the code and the notebooks that we use for fine tuning and running the Slack bot that we talked about, that's at the GPT repo. That's it. We have time for questions, I hope. See a question. 50 minutes. Oh yeah, I was too fast. Well, that's great. Then you can ask questions and I can figure out what I didn't spend enough time
on. It was an example with the chatbot. Can we do the same with, let's say, financial data? Let's say my AI is a trader that receive trading data, like prices.
Yeah, I mean, I think you could. And I think I've heard of people trying to do similar things. I think the thing with financial data, and I mean, Cascada is good for this because it has the kind of structured numeric kind of aggregations and numeric analyses that you might want to do to try to make a more conventional predictive AI. That's one of the things that Cascada started out focusing on. So you can do a lot of the numeric predictive type things. I'd say that the interesting thing, especially with GPT, is you can pull in a lot of the like textual understanding. So, you know, can you pull in news articles to figure out like this news article means this financial thing might move? So yeah, you could, that definitely.
Okay, in this case, another question, like different type of data require different type of storage, right? Of your history. You have like different types of that, or
yeah,
it's the universal one?
We're working on adding more. There are, you know, many kinds of data on the roadmap, but at a high level, right now, kind of Cascada supports, you can bring in anything from Python as like Python dictionaries. And so, you know, think of this as like JSON objects. So anything can be brought in that way. Cascada also supports Parquet, which is a really standard kind of numeric columnar format for structured data. It also supports Pulsar for streaming kind of data with Avro messages and things like that. So there's a wide variety of formats you can use already, and you know, we're happy to add more.
Thanks. Very interesting talk. So one of our use cases that we've been dealing with, we work mostly on conversations, right? And so there are very distinct real-time use cases and very distinct async use cases, right? So real-time is more of you're trying to do things like transcription, you're trying to keep up while people are talking, while people are speaking, right? Versus async is more of you have a lot of historic conversations, you're trying to extract insights from them and so on. So can you comment a little bit? And my question is about Cascada, but also in general. I'm sure you have thought about this as well, right? Can you talk a little bit about the kinds of use cases where real-time AI and real-time assistance makes more sense versus the kind of use cases where we can actually say, okay, this is an async use case and we don't really need real-time. So almost like a sort of negative question. What are use cases where you think real-time is not really required, right?
I mean, I think it's a good question. And I you know, as many engineers may say, I tend to be pessimistic about things. So I resonate with the question a lot. At the same time, you know, some of these things I think have a very fuzzy boundary, right? Like you mentioned, you know, I might have thought the application that I showed up here could have been async. Like, well, you're just telling people, hey, here's a conversation that you might be interested in. Why not give them a daily digest? But I think at the same time, we can probably admit Slack conversations happen faster than daily digests, right? So at what point are we really making this distinction because we couldn't do it in real time and so we want it to be async versus we need it to be in real time? And so I think certainly I agree that there's a case of things that async makes a ton of sense. You know, you want a human in the loop or you want to wait for them to ask a question. But I also think that I would almost ask myself the other question if I was looking for really interesting use cases. Like, why isn't real-time appropriate? Right? Because I think if we assume we can do it, there's a lot of cases where we would use offline or async that we just did it to make it easier for ourselves. So I don't know if that's like a definitive answer, but I think it's yeah. I'm trying to be more optimistic about these things. I think I saw a question over. Yeah.
Thank you. So it's along the same line as the previous question. And I love how Ryan said, like, don't go for fast-paced, real-time stuff. This is really, really hard. So I kind of wanted to ask you, what are the costs in terms of engineering, in terms of cost? I think you were calling OpenAI pretty regularly to run that bot.
Great question. And I think, I mean, that one obviously was, yeah, calling OpenAI basically on every message. But like one of the things, you know, that Cascada is really good at is that you can easily say like, well, only do that if there hasn't been a message in 5 seconds, right? Or, you know, do some other numeric stuff to like figure out like, you know, make sure that there hasn't been like that, there's been a message that's more than 50 characters, but before you do it again, right? So you can start to do kind of almost like filtering. So some of your logic can be done in real time using just Cascada on the events as they're happening, so that you're producing fewer events, fewer calls to OpenAI, right? I could also imagine one of the things that we're going to experiment with in the GPT stuff is like doing, you know, vector embeddings on the messages first to be like, hey, is this message interesting or not? Does it change anything? And then using that to kind of inform, should we call into OpenAI? So I think that, yes, there's kind of the cost of OpenAI, but we can also think about like doing some things to reduce that aren't switching to like an offline or async thing. That's, you know, just applying some intelligence to decide if we should make the call or not. Good questions.
Adding to the previous questions, can you discuss a few use cases from customers today that are using Cascada, both with Gen AI and without Gen AI?
Yeah, I mean, so like I said, I think Cascada historically was originally for kind of predictive AIs, the more traditional, you know, bring a bunch of numeric data, process it, train a model. So we have a variety of use cases there. We're also seeing some use cases in some like financial industries and transaction things. One of the cool things that I didn't talk much about in Cascada is that you can take an event, push it into Cascada, and see the result right away. So if we think about like traditional streaming architectures, this is actually really hard, right? Normally you would like put your event into Kafka, you'd wait for your stream processor to read the event, it would do something and then publish another event to Kafka, and you'd wait for those and you try to match up UIDs or something like that to see that you got it. So kind of, you know, you can imagine that like in the financial industry where you're like, well, I'm trying to predict, is this event fraud? You really want the event that you're about to make a prediction in to actually be in your system before you go and ask the prompt, you know, is this fraud or not? So I think we're seeing use cases there where like that ability to kind of like read your rights is useful in the financial industries. I remember other cases. I don't remember other specific use cases.
Hi, so I know that the OpenAI APIs can be expensive, and especially when you start uploading a lot of data into it, you know, the amount of vector embeddings can, you know, I know the cost can add up quite a bit. Is there any cost benefit analysis to, okay, you know what, if I'm writing a message, it costs me XYZ, you know, because then I can figure out whether I really want to use it or not.
Not that we've done. I think that, so as I mentioned to the earlier question, you know, you can do a lot of kind of pre-processing to figure out, should I make a call or not? Do I expect this call to be useful? The other thing that I would say on that note is there's a lot of work, there's a lot of options driving the cost down, right? Like I think it's this year, next year, you know, a lot of companies are prototyping, the costs are high. I think that's only going to continue to be driven down, right? We can, you know, there's a lot of other techniques you can apply. One of the things we're looking at in Cascada is like applying some of the local models, you know, to two things. And I've even seen people who are like, well, use the local model to decide if you should use the bigger model, because, hey, you can run that cheaply. One of the things that we have talked about is using LLMs to make training data for more conventional predictive AI. I've also seen like concepts like distillation for like taking, you know, your bigger LLM and making a smaller model that's cheaper. So I think that the two things on the cost front that I would be looking at is kind of how do you use, you know, Cascada, use your knowledge of your domain and possibly some cheaper models to figure out if you should invoke the big models, and how to make, you know, make the model cheaper as well. And I think that both of these are going to change very heavily to make it easier to do real time.
Yeah, this is a supply chain related problem. And let's assume you have a bunch of different streams of, it's a supply chain problem and you're trying to create markets for plastic waste. So you have consumers in, say, the Seattle area buying type 2 shampoo bottles, and that uses a certain kind of resin. and you have oil production is producing that type of resin in a stream, and those all have prices associated with them. So what you're trying to do is then figure out if you can get the people in Seattle to buy more type 3 plastic instead of type 2. That'll have a higher value if you get a larger supply of that. So it's you're getting feeds, a lot of different feeds, data points coming in constant streams. You don't need it in real time, the result, to keep the cost down. So would it have applications? I guess.
Yeah, so I think you hit on a few things that I think I didn't touch on that Cascada actually, because it was originally built around these predictive AI things, does really well that would be helpful for that case. So one of the things it does is you can have a bunch of different streams and just work with them together. You know, you don't have like, if we think about like SQL and we have 2 Kafka streams, you actually have to explicitly join those streams before you can operate on them. If people remember my previous talk, I had a big example showing like 50 lines of SQL just to use 2 streams together. But because Cascada is built around this concept of time, you basically say, hey, each of these streams has timestamp data. And it's associated with, you know, maybe cities or something like that. And so you can just work with those 2 streams together, and Cascada will be like, well, I know that I can join them on their key, and I know that I can join them at the times. So like it makes it very easy to work with all these streams in one place. And then the other thing that's really useful in that kind of world is that all of the joins that Cascada does are temporally correct. So if you do a join, you don't get the value, like the latest value, you get the value at the time that you asked for it. And so this is really useful, like when you're going back and making training examples and things like that, because you can go and say, hey, you know, I want to pull in how much was it type 3 plastic or oil was being made, or resin was available when Seattle ordered this much, right? Not how much type 3 resin is available now, but when that order came in, how much was it? And that's all automatic. So I think for those use cases, there's a lot of things in Cascada that would be helpful, even without Gen AI, even without real time.
Thank you for the talk and the question answers as well. So in async models, we have security issues, quality issues. Now you're taking it, you know, more real time. What kind of security issues and quality concerns have you, you know, run into, and how are you addressing them?
So we haven't done too much in that space yet. I mean, like I said, the model that we made was more of a demo of how we can build real-time AI apps. One of the things that we've thought about a lot, though, or that we're interested in exploring in that space, especially for the quality, is, you know, imagine that you record thumb up, thumb down. Was this a good suggestion? Well, it's not enough to feed in the prompts that you have now. Imagine that you're doing Ray, and you feed in all the information that you have now. Of course, the model is going to say something different because it is reasoning about a different point in time than when it made that answer. So if you're going to go fine tune off, this was a good answer a year ago, you better feed in the information about the prompt you would have made a year ago when that was what you did. And so I think that in a lot of these kind of fine tuning cases and quality improvement cases, we're interested in kind of exploring that piece of it, that, you know, as you make this real time, you still need to be able to reason about the past to make really good examples and continue to improve your quality. Not yet. I mean, not beyond kind of, you know, the standard security concerns. I think. Good question. Are we out of time? Out of questions?
Any other questions?
Thank you.
Awesome.